I will just jump in again and welcome everyone to our last Innovation Hour webinar of the year. We are really excited to share with you some details from our 2025 innovation campaign. I'm Carrie Workman with the Office of Research and Innovation, and have the pleasure of sharing this time with you and being able to connect with innovators. We have 5 presenters today who are going to represent their work areas and share their innovations. And Taylor, if you would just go to the next slide, that would be great. I will put we can skip the icebreaker, and I will just say, our 2025 innovation campaign really centered around the desire that our office had this year to recognize and reward innovators and the courage that it takes to innovate. So we really wanted to structure our campaign to be as engaging as possible. We started by meeting with each area and district in MnDOT to ask for your nominations, to nominate one project that you wanted to put into our campaign. We received 30 nominations from across the agency, and they were just wonderful innovations of all different types. So you will have the chance to learn more about 5 of those in more depth this afternoon. And I also want to just thank all of the work areas, all of the innovation team members who were recognized as part of that, whether you were recognized as an award winner or a nominee. Really just appreciate the time and the effort that it takes to implement and bring these innovations to life. It was an agency-wide voting process that determined the award winners for each of our 5 categories. We were really blown away by the fact that we had almost 700 MnDOT staff who participated in agency-wide voting through our online platform, and we had over 2,000 votes. So for our first time in our innovation campaign, that was really a huge successful surprise to us. So thanks to Team MnDOT for helping us really create an innovation campaign that we will continue to learn from. One of the things that was at the heart of our campaign is the idea that everybody at MnDOT is an innovator. And innovation happens in so many different ways. Some people just do it and don't even think about it being an innovation. It just happens. Other innovations might take a longer time to implement. And I'm grateful to the presenters that we have today who are going to share their innovation stories with you. So next slide. Yeah, our innovation strategy is kind of the roadmap for our goals in innovation, for the projects that we tackle, and just as we start to really build and foster an innovation community at MnDOT. We look to that for some definitions of innovation, again, using critical and creative thinking to implement ideas that create value for our agency and the public we serve. I will drop a link to that strategy at the end of our time together today, just to see, if you would like to check that out as a resource. It includes some other wonderful nuggets of wisdom as we use this document to guide the development of our innovation culture, one of those being the E3 mindset. Maybe some of you joined webinars that we did previously in the last 2 years focusing on these 3 E's: empathy, experimentation, and empowerment. And the presentations that you hear this afternoon will certainly reflect these three components. Yeah, and we are really excited. We did have an recognition event on October 30th that brought together all the nominees and their innovation teams to share just some space around for recognizing and rewarding innovation in a more celebratory way. We had 5 innovation campaigns this year in our campaign. These are subject to change as we learn and grow. We did receive innovations across all of our categories that were nominated, which was really wonderful to see. We have an Innovation of the Year that received 10 nominations during our campaign, 10 projects put forward, 9 nominations for our Spark Award. We had a Flow Award for process improvement that received 8 nominations in that category and 3 nominations for our Upgrade Award. So today we had a People's Choice, and all nominations were eligible for that. So happily for us today, we have the award winners here with us, and we are going to jump right into the presentations today. We did have some guiding questions for each of our presenters as they thought about their innovation, sharing with us the problems they were trying to solve, how long their innovation took, some of the challenges and some of the really wonderful things about working on innovation, and just anything else that they would like to share. So I am going to introduce our first award-winning innovation project, the winner of the 2025 Spark Innovation Award. The project's name is the use of the 3D printer to make custom parts for traffic signals and ITS. Today we have Tom Christofferson from the Office of Transportation System Management and Operations here to share some more about this wonderful innovation, the Spark Award. So I will turn it over to Tom to kick us off. Thank you, Tom.
Thank you. So yeah, first things first, I'm Tom Christofferson. I also partnered with my dad, which is Ron Christofferson, on this award, but I'm the main presenter of this. We use a 3D printer for prototyping and custom parts for our department here at ESS in Fort Snelling. On to the next slide here. All right, so the printer that we that was purchased is called the Prusa XL. The 3D printer is capable of printing different types of materials. So it'd be like PLA, ABS. There's a few other things that we do too, other materials that we use, but the main two are going to be PLA and ABS. Like I mentioned before, we use this 3D printer for prototyping parts and then also making parts for us as well. This printer is capable of printing up to 5 different heads, so you can do different types of materials in each head and also different colors as well. Scoot to the next slide. So how it works, because this gets a little bit confusing for some people, how it works is the filament comes in through the top there, and then it goes through a heating element. That heating element itself can go up to about 400 degrees C, and then that melts the plastic. And then when it comes out of the bottom of the nozzle there, it prints in layers, just like, think about it like as a normal like printer basically. So it'll print the first sheet, and then what it'll do is when it's done with that, and then it'll go up to the next sheet and then print over that. And then over time, you'll just get your parts basically. Next slide. All right, so some of the things that I made with the 3D printer that I thought it was really useful is the biggest thing is our video detection system cameras. These are Bell cameras that are made from GridSmart. The biggest issue that we were having is we were getting these cameras back from intersections, and the lenses themselves would get scratched, or we've even had a few of them that are broken. That's about a $3,000 just to replace that camera itself. So I wanted to make something that would protect that lens from getting damaged. So I developed a part that would clip onto that camera and help protect it. So again, that would be just from storage or transportation out to the intersections or coming back. On to the next slide. Some of the other things that I was running into issues as well, inside of our traffic management cameras, we were having issues with people taking slots out of the cards and then putting it into a slot where it shouldn't have been. So I wanted to create these blank out cards that would go into the racks. This just kind of helps with labeling and then just easier troubleshooting process. Because if one of our technicians are out late at night, at 12 a.m., it gets kind of confusing and you're just groggy. So if you take something out, it's just kind of mindful that you're just going to slide that card right back into where it should have been, basically. Do the next slide. And again, kind of explaining the same exact thing. This is on the backside of those traffic management cameras. This is just also, I wanted to develop these as well. They're dust protectors for these slots. Basically, they're slots that are not used on the back of the cabinet. Just it prevents dust and debris getting into those slots. And again, we have more labeling in there as well, just for easy troubleshooting. On the next slide there, these blocks are kind of reflecting back on the previous slide. So it was a little fun project that I wanted to do, is because we paint those colors on these terminal blocks to help us land. They're called EVP wires. So basically it's just wiring for inside the cabinet. So I wanted to build a little template that would allow us to you have couple coding for just easier troubleshooting, basically. So they just slip right in and then you're able to print the colors on there. So that pretty much concludes all of that. Like I said, the 3D printer is for, we've purchased it for something that would help us develop stuff that a manufacturer doesn't have. The department that we mostly that we worked with was the CAB department on this. So I'd love to give them a special thanks for partnering with us on purchasing the 3D printer so we can make these, parts. So that's all I pretty much have for all of that. I guess we can open it up to questions. Everyone's muted?
I see a raised hand.
Yes. I don't know how I'm going to answer that. Let's just pop over to chat. How many different parts have I printed? Right now, I'd say about 5 or 6 different parts. We are partnering with the U of M as well. So they're developing parts. So we do have other departments in Minnesota that are coming to us, and then that was a whole goal of the 3D printer itself, is to partner with other people. So if they had something, then we could print it off. They could print it off too. The U of M is mostly using it for prototyping inside the plow trucks. So, any other questions? Yes. So CAB, yep, connected autonomous vehicles department.
We have a question from a raised hand, Marcus.
And I think I allowed you to unmute yourself, so that should work.
Yeah, we should be able to unmute, and we'll kind of go back and forth from hands raised in the chat.
Perfect.
So, Marcus.
So, Tom, I have a idea rattling around in my head for something that for wire labeling. So, I guess as a sort of general workflow, what do you guys have established for requesting or designing? Just coming to you. Hey, what do you think of this? While you're trying to do something else.
That's kind of the tricky part, because I don't really have a true process for that yet. I've had a lot of people just come up to me and they're like, we have an idea. Basically, I'd like to sit down, with an individual and then kind of figure out how how they want something developed, just kind of talk through the process to figure it out. I don't have anything quite yet set in stone for something like that yet, but my biggest thing is, just sitting down with a person and trying to figure out what they want, and then just start going through like a prototyping process.
These are all such great questions. Thank you. I'm going to give you another one from the chat. How
Okay.
do you get the different coloration in the parts? Is it a second filament being used, or is it a sticker/paint?
Do you have the ability to go back on those slideshows?
Yeah, Taylor,
Yes.
can you
Yep.
jump back
Go
a few
back.
slides? Thank
Can you go back to
you.
introduction?
Sure.
Yeah.
This one?
Yeah, there we go. So it might be kind of hard to see for some users in there. So the 3D printer itself, like I said, it does have 5 heads on there, and each one of those heads has a preloaded filament, as you can see, like in those little boxes are on both sides of the printer there. So each one of those boxes has a different color filament or a different type of plastic, and then that gets fed up into the actual 3D printer itself. So what the 3D printer will do is actually smart enough to know that when it's time for a color change, it'll park the initial first head first, and then it'll go and pick up the other head, and then pull that out, and then it'll start extruding that color or different material onto the print. And that was the biggest reason why we picked this printer, is because of the efficiency of that. There is other printers out there that are capable of doing it, but there's a lot of waste involved and time. As of right now, this is the fastest one on the market right now for it. So there's other ones that are in the makings right now that are substantially faster and do a better job. But at the time of purchase, this was the number one. So hopefully that helps explain that.
Yeah, thank you. Great question. And one more, well, two-parter. How did you design the parts, and what software did you use?
So starting with the software, so the 3D printer itself has a software that helps convert the part that I developed or anybody developed into the machine code, basically. That software is called Prusa. Yeah, Prusa, to help with that. As of like the software for like 3D designing, I personally use Tinkercad, but I know MnDOT and a couple other guys here too were working on a piece of software, because what we want to try and do is future-proof this machine. So if somebody else wants to use it or develop a part, we want to be able to figure out a software that's easy to learn, and then fast produce a parts, basically. So we're still working on the official software for MnDOT, basically. But we are licensed and approved for the Prusa Slicer software for this printer.
Okay. And when you have a moment, Tom, there's one more question that if you could respond in the chat about a good website to learn more about 3D printers, that would be appreciated.
Yep, I will. I'll take care of that as we're going through. So, yep, I do see a few on here, so I'll answer to those.
Perfect. Thanks so much.
Thanks.
All right. And that was our Spark Award winner. And certainly a fantastic idea that has a lot of interest, and I'm sure we're going to be hearing more about that innovation. And our next award category that we'll hear from was our Upgrade Award winner. And the Upgrade Award was really designed to honor ingenuity, adoption, adaptation, and or resourceful problem solving uses the resources that we already have available. And today you're going to hear a project called Project Bundling, Pedestrian Bridges in Multiple Districts, excuse me. And we have Peter Davich here today to talk with us from the Office of Construction and Innovative Contracting to share a little bit more about this innovation, and looking forward to hearing about that. We will again stick with the format of letting the presenter share his slides and then opening it up for questions. And thanks so much, Tom, for earlier. Welcome, Peter. Thank you.
Yep. Thanks for that intro. I'll try to go through here in a few minutes. Yeah, so design build is something that's obviously been around for a while, and we're not really on the innovation list before, but for upgrade, this is a kind of a use of design build that we have not used in specifically this way before. And yeah, just for the introduction one more time, I am Peter Davich. I'm the design build program manager in MnDOT, and I've held that role for, what is it, 13 years now. In any case, we have a statewide pedestrian bridge improvement design build project here. The issues that we were kind of looking at, really the leadership high level before this project came together, were that, we have a statewide inventory of pedestrian bridges. Many of them actually have ADA non-compliances, which isn't good for a pedestrian specific facility. Some of them actually have structural needs. But we have trouble kind of getting pedestrian bridges in particular in the usual program. Usually they kind of wait for a roadway project to come along by, and then they kind of get tacked on the side. A project that is specifically focused on ped bridges is quite rare. In this particular case, there happened to be, luckily, some carbon reduction funds that the department was given that were relatively, it's a new funding group, and it didn't have a specific idea for exactly how it would be spent when the funds were allocated, except that they needed to be used to kind of work on, modes of transportation that were not adding carbon and would ultimately reduce carbon usage in the long run. And another issue, as everybody I'm sure is aware, that there are generally staffing shortages in the districts and kind of across the department, and kind of everybody's stretched to the brim with projects already. The solution in this case was, well, you know what? We could bundle these projects into one statewide project, as opposed to trying to get different contractors to do this and kind of tack it on to other projects awkwardly, really who knows when. Let's do it all at once with a contractor who is mobilized specifically for pedestrian bridges. Let's furthermore have them use design build to kind of design the solutions at the same time, given that they're kind of a unique set of ADA solutions, kind of see how that works. And we'll actually run it centrally, as opposed to, air quotes, bothering the districts with this. Let's see if we can get the central office to kind of do these in a few different districts with some central project management, and see if we can get it out easier, more efficiently that way. We can do next slide. So we looked at 20 plus bridges around the state. This was Tony Lesh working in the bridge office at this point. They were looking most specifically at ADA, and also whether the structural needs of the bridge would really make it worthwhile to address that one in particular. They were looking for projects that would have relatively minimal permitting and other complexities with it to make sure that these could be bundled together without having to do complicated permitting efforts. The idea was to allow the contractors to be able to work over these bridges really whenever it was convenient for them over a 3-year period. And just with the same logic, we wanted no right-of-way. I put asterisks on those because those are kind of the project joke. Of course, moving forward, this is supposed to be simple. It wasn't supposed to have right-of-way. In reality, as with every MnDOT project, there were complexities and there being some right-of-way, but that was the idea. Good, I got at least one laughing face. The budget ultimately allowed for 4 bridges. They were a major pedestrian bridge near the Twin Ports interchange in Duluth. They were in Glencoe in District 8, and there are two were in the Metro District in St. Paul and South St. Paul over 35E and 52. Next slide. Yeah, so I can kind of say the benefits and what's different. I mentioned these. It's a statewide scope. It was run centrally. We did minimize the district involvement. Obviously, they need involvement to know what we're doing. We need to kind of keep coordinating with them, but we tried to minimize the resources they would need to spend on it. And this was a newer attempt to pair ADA and design build. We kind of tried some different models for doing that. This was a newer attempt. Ultimately, we let the project to AIMS as the contractor with Alliant as their consultants for $13 million, which was relatively near our engineer's estimate, so we were pleased with that. A few lessons learned along the way. like I said, there were, of course, permitting and some right-of-way issues that popped up. And most specifically for permitting, the contract was written for a single location. Again, it's a statewide one contract, with the permits being kind of in different locations. It wasn't that it was not possible. It was just kind of awkward in times to kind of explain how this is one project in different locations in the environmental process in particular. Possible, we kind of figured out how that would work, but a couple speed bumps. And both centrally for the district, I think both groups would say, you know, if we're running it centrally, but we're needing to stay on the radar of district functional groups, whether it's right away or utilities or what have you, there's not kind of the natural coordination if you're sitting there and doing it in person. So there needs to be good structures to make sure that everybody's aware of who's doing what, and we're kind of on the priority list for all of them. Again, nothing that would stop us from using the method, just some lessons learned. Again, the idea was to balance it so we weren't being burdensome. And last slide, I think. And I should mention, I meant to say that from the start, so I was involved with this project as it was kicking off and we were selecting bridges and kind of procuring the contractor. Luke Johannek has really been the person running this project ever since and kind of learning these lessons for us. And he wrote most of this presentation for me, so I would be negligent if I didn't mention his name here. In any case, should it be done again? Was it a good innovation? I would say yes. I think this is a good model to use. If we have these awkward work types that don't fit easily into other projects, if they are especially in need of specific contractors that have specialties and can kind of use that specialty in different locations, maybe ITS, maybe landslides, maybe culverts, maybe bridges again. It does help address maybe district resources, kind of bundle things together. And if you have a question, you can contact the alternative delivery group to see if something fits. I think that's all I had.
Thank you so much, Peter, for sharing your upgrade innovation. Yes, thank you. And opening it for any questions. You can either raise your hand or by putting something in the chat. Patrick, I see a hand raised.
Peter, I won't put you on the spot with a question, but since we got one of the bridges on behalf of District 1, thanks. That was really, it was appreciated by us in a good process. So thanks on behalf
You don't have
of
it
District
yet,
1.
just to give you a disclaimer.
Yeah, well,
So-
there's my question. Where's our damn bridge, huh? No, we know it's coming. Thank you for your efforts and Luke.
Mhm. Peter, how
Very good.
long
Thank you.
did this take to move forward and kind of really, yeah, if you could just give us a little sense of that, it'd be great.
I think we spent about 6 months putting together the preliminary plans and kind of scoping out the bridges, and then had another 6 months where we were getting into procurement. So it was about a year development process. And then it's been, again, a long construction period because the idea has been to give the teams 3 years to work on it. We'd hoped they'd kind of spread them out better over the 3 years with doing some design issues and working through things. Most of them have kind of drifted to the last year, which will be this upcoming year for construction. But it's on track and it'll be moving forward.
Thank you. Any more questions? Okay. And if anyone has any later on, feel free to put those in the chat. And, you know, really even just hearing about our first two innovations, we hope that what you hear today might inspire you to think about utilizing the existing innovations in your own areas, either adopting those or adapting them. Really interesting process innovations, equipment innovations, and we are going to move on to our third award winner, which was our Flow Award for implementing a new or redesigned process that achieves excellent results. So we are looking forward to hearing from District 1 about their Blatnick Bridge permitting process innovation. And yes, going to hand it over to Pat.
All right, thanks. I'm Pat Houston from District 1. I'm our MnDOT district lead for the Blatnick project, which is a really big one, $1.8 billion that we're doing with Wisconsin. So it's a big team project. Next, please. I want to make clear this was not my idea. So really from the idea point of view, it's John Krishak's our project manager and Matt Meyer our District 1 environmental coordinator came up with this idea. And you'll hear me talk about collaboration and communication, and you might say, why is that innovative, Pat? And it's not, but the way we implemented it was. And also a special shout out to Keith Malnow, who was a key collaborator through the process. So I'm just here to share the story. So the problem we were trying to solve is at a $1.8 billion project, inflation is $80 million a year. So obviously every year we can shave off the schedule, that's $80 million. We also need a lot of permits, 14 to be exact. So how can we best work together to educate and collaborate as we go? We don't have time to back up. Our motto is kind of no surprises for anybody. And I think I saw Lynn Klarkowski on here a couple projects ago, kind of in the same context. When I hadn't engaged Lynn's unit yet, because I didn't think it was time, she told me, if you don't tell them, they just make it up, right? So I'll explain that more later. Some of our challenges we had was accelerated project delivery. Like I mentioned, we're obviously trying to do this as fast as we can to save money. Peter talked a little bit about design build, and he's leading us on that, but design build really adds some complexity to permitting. And by that, I mean, typically when we work with permitting agencies, we have some sort of plan to look at and go over things, where design build, you don't have as much up front. Also, in that effort to collaborate, we have issues to address like temporary works, which would be, you know, how's the contractor going to get out to do demolition and construction, bridge demolition, that sort of thing. So we really need to collaborate heavily with the agencies to do that with not as much information. Next, please. So who was at the table and for how long? Well, let me say it this way. Typically in my career, it's kind of interesting. We typically work with the agencies that give us permits more in a one-on-one. And so John and Matt's idea was, let's get them all to the table and develop the project as we go together, and the permits will follow along with that. So you can see who was on there. It doesn't look like very many, but with our core team and our specially functional leads, these bi-monthly working group meetings got pretty big, and we did them for 4 years. And the goal was, let's meet all of our goals as we go. And if you think about having all these agencies at one time as stakeholders, might not be time for one or the other, but they all pick up on things and do some springboarding. So it was really a useful process. Next, please. So I talked about this. What it was early and continuous communication for 5 years with all the permitting agencies and our SMEs, which is subject matter experts. So we brought everybody along with NEPA, our environmental process, and project development and preliminary design to get it right the first time. Getting it right meaning getting our design nailed down to meet everybody's expectations. And the benefit is, so when the permits finally go in at the end, we've had so much engagement, it's just kind of a sign it and go. And that's kind of the way it turned out. Point is, start early. Next, please. So in our case, this led to a permit matrix that John and Matt also came up with. But typically when we work one-on-one, everybody being agencies, they know what their stuff is, but they don't know the big picture like we do. So that's why a matrix with all the relationships between the different permits and a timeline were developed. So Matt and John and the team kind of came up with that, and then engaged the agencies who bought in, and actually they were just like regular team members, and everybody met their deadlines. Next, please. I know you can't see this, and normally I would pop out a PDF if I was presenting, but this is kind of the flow across the top, or all the different permits, or most of the major ones. The arrows represent how they depend on each other, and what you can't see there is our date and flows, which we put into P6, which is our scheduling software. Next, please. This is one example just to illustrate what the benefit of this was. So you're looking at a top view or a plan view of the Blotnick main span across the St. Louis River. Those green kind of vertical lines was our first concept at pier protection to help prevent ships from hitting the piers. And basically think of them like islands. We thought that would be good without putting in more man-made structures. There were some advantages. Next, please. As a result of getting input, which we'll see on the next screen, this is a representation. There will be more than this. Now the green dots are what we call dolphins, big man-made structural protectors in front of the piers. And there's a lot more than that. Next, please. So just one small snip, I'm not going to read all this, but what we heard from the agencies, this is just some of the Wisconsin DNR feedback, but we heard it from the Corps and the Coast Guard and others, but wanted to limit the amount of fill in the river. We don't want to lose habitat, won't want to restrict the stream, don't want to degrade water quality, etc. Then they didn't want terns to nest on those, and there's a protected tern in the area, and if they nest on it, it makes it harder for us to do maintenance. We also wanted to minimize disturbance on potential contaminated sediment. So if we would have done it the old way and we would have just worked with one agency at a time, we'd have probably gotten too far down this path and then had a backup and lost schedule. Next, please. We'll just zip through these. I'm not even going to read them to you. 14 permits, and we are 13 of 14 complete. And there's a couple of you on here that know our project manager, John Krishak. He even beat his own schedule. So I'm very proud of these folks and everybody that worked on it. Next, please. So takeaways and summaries, whether it's a big bridge project or just any problem you're working on, I think this is scalable. I guess my message to everybody that I wanted to share, in addition to recognizing John and Matt, is when you have everybody at the table, we're better together than separate. So we've learned time and time on our last 3 big projects, when you're struggling with something, get everybody to the table and talk it through and bring everybody along, and you can come out with some good results a lot faster. It's not rocket science. That's it for me.
Thank you so much, Pat. I feel like each of our presentations could be a webinar, an Innovation Hour webinar on its own. Definitely, yeah, learned a lot through that. Thank you, about coordinating with DOTs across states, across agencies. So much good information. Questions? Any specific questions? Okay, I guess, did you know of, or maybe the project management team know of anything like this previously, or was the idea just to redesign what had been done and try something to hopefully create more efficiency, which you have?
It was just knowing that we had a really tight deadline. And I think thinking back on it, every time we, like through Twin Ports Interchange and even up at Virginia, when we struggle, it's like, hey, why don't we just get everybody to the table? Why don't we get everybody to the table? And we oftentimes forget that, right? And so I say, sometimes it's obvious, but there's a lot of veterans on this project. And I kept asking everybody, we ever done this before? And nobody can remember doing it. But again, whether it's a project or anything else, it's really been helpful to just collaborate and get people to the table, even if you don't think it's time for some of them, because that prevents bringing them in later and just saying, why don't we do this? Why didn't you do that? It's like, don't worry about it. We figured that out 2 months ago, right? Get everybody on the same page as soon as you can.
Yeah, the collaborative piece is so powerful. Thank you for highlighting that. Okay, we have a question in the chat. Did you find more success mapping out timelines by walking backwards from the deadline or starting from the beginning? Thank you. Great question.
That is a good question. On this particular issue, we knew where the end point had to be, so we walked it backwards from there. The bigger thing, if you look at the project as a whole, and for everybody in here that does project development, you've probably seen this. I don't know how many times in my career said, hey, can we do this by 2025? Can we do it by then? We always develop a schedule and see where it lands, and then we look for opportunities to shorten it. But in this case, for this particular effort, we walked it backwards from when we knew it, the permits. We needed the permits.
Wonderful. Yeah, we did a webinar on starting with the end in mind as part of our experimentation, and that just definitely calls this out, working backwards. Any more questions for Pat? We're moving on to our next innovation. Thanks so much, Pat. And next you are going to hear from Ethan Peterson in the Office of Traffic and Engineering, our Innovation of the Year award winner, a project that is titled Enhanced Pavement Striping, Increased Life and Visibility. And in our nomination form, we also asked for an alternative fund title. And we also will refer to this project, as I can see clearly now, even if the rain isn't gone. So definitely appreciate the levity of that, and just want to recognize the Innovation of the Year really stands out with having an impact and also advancing our MnDOT strategic priorities. So here to share this innovation as part of the team that worked on this is Ethan Peterson. So thank you, Ethan, for your time today.
Good afternoon, everyone. This is Ethan Peterson with the Minnesota Department of Transportation. I am the state pavement marking and crashworthy engineer. I'm here today to present on the study Pavement Markings Wet Retroreflectivity Standards. This study was sponsored by the Local Road Research Board and the Minnesota Department of Transportation. It was conducted by the Texas A&M Transportation Institute. The goal of the study is to provide a pavement marking that can be seen in wet nighttime conditions, which continues to work toward the MnDOT goal of providing an appropriate pavement marking on all highways 365 days per year, as set forth in the MnDOT provisions for pavement marking operations tech memo. An appropriate pavement marking is one that meets or exceeds the standards defined in the MnMUTCD. And of course, during winter weather events, pavement marking should provide presence after pavement is clear of snow and ice. It helps to also look at the possible benefits that could be achieved through the use of wet retroreflective pavement markings. The study safety evaluation of wet reflective markings found that a 14% reduction in wet road crashes was observed on freeways, and a 25% reduction was observed on multi-lane roadways, as seen depicted in the graphs on the slide. Now we look at the inner workings of the Pavement Markings Wet Retroreflectivity Standards study, the test procedure. First was the wet conditions testing. The participant was driven up to the beginning of the rain tunnel and, from a stationary position, counted the amount of skip markings that were visible to them. This was set up in the MUTCD standard 10-foot marking 30-foot gap. From the number of visible skips, the observation distance could then be calculated. After the enumeration of the skips, the participant was then asked to give a 1 to 5 subjective rating of the pavement markings observed. As seen in the picture here, 2 pavement markings with varying wet retroreflectivity were observed on each lap through the rain tunnel. There were also 2 different rainfall rates that were applied in this study, 1.5 inches per hour and 2.5 inches per hour, both of which are considered high rates of rainfall. The second phase of the lap through the closed course was a dry conditions test. The 2015 Ford Explorer approached an isolated skip at 10 miles per hour, roughly, until the participant indicated that they could spot the pavement marking. Then this distance was recorded. The participant was then driven to a distance of 30 meters out and asked to subjectively rate this marking as well. After this, the lap was completed, and the markings would be changed for the next lap. This slide shows the dry condition phase of the testing, with a larger picture showing the participants' maximum detection distance and the inset picture showing the 30-meter distance that was used for the pavement marking subjective rating. To really hone in on what wet retroreflectivity levels should become the new standard, 1,209 human factors observations were recorded. Of those observations, 403 were in dry conditions, 162 were at a rain rate of 2.5 inches per hour, and 644 observations were at 1.5 inches per hour. This consisted of 20 marking samples, 11 of which were white and 9 were yellow. The dry retroreflectivity of each sample ranged from 35 to 1250 millicandela per meter squared per lux, and the continuous wet retroreflectivity ranged from 21 to 480 millicandela per meter squared per lux. Another important aspect of this research project was capturing the right demographic of the driving population. As you can see, the 43 participants' average age was 58.5 years old. Older drivers need brighter markings for the same level of visibility compared to younger drivers, which is why the participant demographic was skewed toward older drivers. Just as a quick refresher when looking at this, a Snellian visual acuity of 20/20 indicates normal vision at 20 feet. So 20/40 indicates that the observer would need to be 20 feet away from an object that people normally see from 40 feet. Looking at the visual acuity of the participants, we see 28 are below the average eyesight. This is also helpful in setting a standard that will cover the majority of the driving public. Now that we've covered the why and how the research was completed, we can move on to what was discovered through this research study. The main takeaway of this research was that a continuous wet retroreflectivity level of 50 millicandela per meter squared per lux was adequate to meet the average needs of participants in the study on roadways with speeds of 60 miles per hour or less. This value was based on maintaining approximately 1.9 seconds of preview time, which affords the driver enough to maintain their lane positioning. So this should be our goal for a minimum maintained wet retroreflectivity value, aiming for the value and looking at limited installed degradation rates in the state before the project. A minimum initial wet retroreflectivity of 200 millicandela per meter squared per lux for both white and yellow pavement markings was suggested to maintain levels above the minimum maintained level for about 4 years. A nice thing about these readings is that they can be done through our current mobile retroreflectometer contractors. So it's been easy to tack this work on. A special provision has been established to require the minimum initial continuous wet retroreflectivity and requires readings 14 to 44 days after the installation of these markings. This special provision has been the standard since 2022, and as time has gone by, MnDOT has been tracking pavement marking wet retroreflectivity on 32 projects, and the markings have predominantly maintained retros above that minimum maintained level of 50. I'll probably just jump in here. Yeah, I just wanted to say thank you to everybody. Presentation by saying, yeah, oh, there it goes. So
sorry about that.
That was really fun to awkwardly watch myself narrate a slideshow. Thanks everybody. And also thank you to the group that really helped push for these wet retros. It's really been something we've been building on for, couple iterations of pavement marking engineers before me. And definitely wanted to say thank you to Mitch Bartelt, Michelle Moser, and Ken Johnson for everything they've done up until this point. I really think that pavement markings have benefited huge from everything we've done, and even especially this. So we keep on improving, and it's been great.
Yes, thank you. Definitely a huge safety innovation. Questions about what Ethan shared?
One thing I'll just add quick is that when we went through this, we had a good feel for what dry retros meant, right? So we could take wet retro readings, but we didn't quite know what they meant. Because again, we're seeing how well can you see them in night, dark conditions, whereas dry retro, you can kind of tell with your eyes, but it's not completely the same, right? So the two are on different scales. A 100 dry retro for a white marking means we need to restripe that. 100 wet reflective white marking means it's a pretty good marking. So So we kind of knew they weren't on the same scale, but we didn't exactly know what it meant. So the human factor study was huge with that, because then we kind of knew that 50 for a wet reflective marking was a little more equivalent to 100 for a dry. And this is information that was really the first of its kind in the nation. The other states have very much stolen and copied this. So this has been, Ethan was a technical liaison for this one. He took this to the finish line and got it there. And TTI was a really good partner for research. That study setup was just amazing. If you look at the pictures, even more than meets the eye. So this is something that's, it was really high-minded, cutting-edge research, but it also has been really practical to use.
Yeah, thank you, Mitch. Yeah, definitely. I can see this as innovation that you're going to continue to learn from, and we'll look forward to keeping tabs. Thank you for taking the time to present today. Okay, and we are getting close to we have to our end, but we have one more project, and this is the innovation that was selected by everyone who voted on our platform, or the majority, as Team MnDOT's favorite innovation of the year. This is our People's Choice innovation, and we have featured this project in a previous innovation hour, and here to share the project, the controlled modulus columns, or the soft soil solution, is Adam Arndt from D8. So thank you, Adam.
Well, thank you very much. Very glad to be here. I see Kelly Brunkhorst, our district engineer, is also online. She was also part of the team. Like I said, good afternoon. My role here in District 8 is I'm the resident construction engineer out of the Wilmer office. So as the title implied, this is the soft soil solution. Most everyone knows you can't build a good road on soft, squishy soil. So that was kind of the problem we were solving. It was wood piles, and we swapped wood piles out, which were in the plan. This is all done during the construction phase with concrete inclusions or controlled modulus columns. So something that applies to all of the innovations listed today is, what are you kind of overcoming here? I kind of was raised up in the project management end of the world, at least in my early years, where in this triple constraints, as big issues pop up, you get to choose two. You don't get all three. So if something pops up, you can choose time and cost. Your quality may suffer. If you choose to hold cost steady and quality steady, your time may suffer. But through the magic and synergy of innovations, and this one included, this one especially we're very impressed with, because it took less time, it cost less money, and the quality was about the same or better. So once again, we feel like this one was a really big winner. Next slide, please. And there again, when building road over something we'll call it peat or high organic soils, there's different solutions for them. Of course, in our plans was the wood piles, but you can compress it with surcharge if you have a couple months, which in this case, we did not, because it was planned for wood piles. In District 8, we've even floated over this with mountains of geofoam. But this is just done for illustrative purposes, showing the soft, ooey gooey stuff. If you built a road on that, it would fall apart in a year or two or three. Not good for a 4-lane, especially when you want that road probably bed to be there 100+ years. Next slide, please. Here's the location. We finished this project up a year ago. It was a 2-year project, and then we were really blessed. It was like building through a gravel pit for most places, but in this one spot between two wetland areas / lake areas, Long Lake over to the right there, very nice lake with populated people, all the docks and everything along there. This is this one part where there was peat up to 50 feet thick. So normally you could just remove it easily with graders if it's shallow or in small spots. But this is one spot. There again, the plans called for wood piles. Optimistically, the contractor was looking at 2 months to install, probably more realistically, maybe up to 3. We don't know how long it would have took, because they proposed a swap, and this is done for illustrative purposes here too. This is what wood piles look like. It's an old, trusted This goes back to the beginning of humanity. Humans popping in wood piles down to solid foundation type material and building on top of that. So again, just a picture. Next slide, please. A subcontractor actually approached the prime contractor and said, look, you know, we do egg structures, things like beet piles, potato piles, giant grain bins, but we've been branching out into the road construction area. And we didn't know it at the time, but this was actually the third time MnDOT has successfully attempted that. I don't know the stories of the other two areas. I know one is Twin Ports Interchange, and I know the other project, the first I believe was 9 Mile Creek. So we teamed up with our expert, Rich Lamb, and he was instrumental in helping us listen and understand and go through the numbers and really understand the contractor's proposal. Next slide, please. It's just some simple mechanics. It's a drill bit with a flap gate on the end. They go down to that hard pan or bedrock, whatever's available, just like a bridge. They drill into that 3 feet, 4, sometimes 5 feet to get a nice solid foundation. And as that drill bit is pulled up, they have all kinds of height, like 5, 6 different hydraulic gauges. Concrete grout is injected in there. So instead of a wood pile, you get a nice concrete pile as that is pulled up. Now our soil was extremely soft, and like I said, up to 50 feet deep of peat. And so when they put that down, they really didn't even have to drill. It was a matter of a minute or two, they were done with each column. So it probably went faster than they even planned in the first place. I mean, it just sunk right in. They drilled a little bit down at the bottom to get into that hard pan and bedrock, and then they went on to the next pile. It was a very fast process. It was fun to watch. And worldwide, they've only done about 2,500 of these. And like I said before, primarily in ag-based or building-based type uses. You know, full kudos to the team and to the prime for listening to this subcontractor trying to branch out. One of the things that really helped us during construction, not to be confused with the value engineering process that happens during program delivery and sometimes pre-design where they look at hypothetical numbers. Spec 1408 allows swapping of something. If you can show MnDOT that it's better, faster, cheaper, it will, we can take a look at it and they can get the appropriate monetary award for that. So here's right out of their proposal. Here's our original bid cost. Like I said, this is as bid during construction here, 3.3 million. Here's the revised cost dealing with controlled modulus columns, 1.9 million. For District 8 MnDOT, our savings was $1.45 million. Of course, there's a back change where that's the spec, what the spec 1408 is talking about, where to really encourage the private sector and get them to collaborate with MnDOT and other, you know, subcontractors. In this case, they do get a 50% back payment on that. But of course, they had to save the 1.45 million, improve it, and stand by it in the first place before they got that payment. So win-win for us, win-win for the prime, and win-win for the subcontractor. And this literally only took 2 weeks. Here's the actual picture from out on the job site. Of course, we built a building construction platform first, which is actually, as we look at it here, sinking into the peat. But they're out there, and it takes so long. It was very efficient to install these 723 in all, which was slightly less than the wood pilings, which was slightly over 1,000. That once you get in there and put these, the load bearing platform here sinks into that structure. You add a little more geotextile on top, and then the settling stops. But out here, we could, as you could see, we could drive around and get the big equipment out there, but it didn't. It's actually in a condition of settling until you get those controlled modulus columns installed. Next slide, please. So what was all the controls? As I mentioned before, there's several meters, hydraulic meters on here, and that's really what this company was known for. It actually started as a testing device company. And I think that's all I'm showing here is that, how do you know, next slide, please. For each and every column put out there, we get this data sheet. This represents one column. You can see up there number 607. And all this data here, which of course we can bring back to our road and materials, or our foundations unit. And of course they say, yep, it's all good. One else, kind of a innovation spinning off into another innovation. District 8 is big in digital construction inspection. So also every column out there, we GPSed. So if we ever do have any problems out there, we'll know right where it's at. It's all in the construction file. And like I said, each one of these data sheets goes with one column. So we ended up with 723 of these. I think that's all I had, unless Kelly wanted to add additional comments or statements, but we can open it up for questions. Thank you.
I just want to thank you and the team, Adam, for implementing this and taking it to implementation.
It was a fun one. Everyone listened and we all learned a lot. Thanks for being on our team. For those of you who don't know, Kelly was our ADE of construction back then. Obviously now our district engineer. So thank you, Kelly, for being on the team as well.
All right.
Thank you both. And Adam, we do have some questions in the chat. The first, I'm going to just read it. When are vert drains a feasible option for dewatering mucky soils?
I don't know the answer to that. I would defer that to Rich Lamb. There was drains also installed. I think that's what you're referring to, the wick drains. I think that was done more as a bonus than anything in this case, because they were the product we really bought off on were the controlled modulus columns. I know the idea behind them though is to get rid of that original high pressure water that may be, kind of latently holding in the subsoil there. I've heard they work well. We have them out there, but they were done as kind of an ad hoc onto this. So Rich Lamb may be able to answer more. I don't know if Rich is on or not.
Yeah,
Let's see.
Can you hear me?
Yeah.
Yes.
Oh yeah.
Let her rip, Rich.
So the quick answer is that organic soils, they consolidate two different ways. Initially they compress or consolidate when you squeeze the water out of them. And that's where wick drains could help, but they also experience secondary consolidation, which can be just as much as the primary consolidation in some poor soils. And so that's just where the organic fibers break down over years or decades. And so it doesn't matter how much water you squeeze out, you're still going to have compression, additional ongoing settlement of the organic soils. So the wick drains were used by the contractor to help them install these columns even faster, because it reduced the pore water pressure near the columns. So it reduced some of the problems, and actually wasn't required as part of the initial contract. So
Thanks, Mitch. Yeah, and a couple more quick questions if we can. I know we are running over time, but due to some tech issues in the beginning, we're trying to cover some more time. Question, how deep can your GPS read?
I have two. That's also a two-part answer. One is as deep as the person holding the Trimble unit can go. So basically just on the surface. But through our 3D plans, we could show how deep each column went, and that you can read off of that data sheet how far each column went. And they were not all the same depth. They went probably from 20 feet down to that 50 feet. The actual GPS is just going on the surface and marking it, but we also have that ability in the plan. We can make it look 3D and look at it that way. If there were ever any failures or anything like that, we could look at it, spin it, look at the bottom, and our data. And of course, so that would be the way that we can do that. And then I see was there any testing performed to determine the homogeneity of the concrete column? Yes, it's part of this package. The subcontractor, who is Menard, also provided the the engineering. So they became their own engineer of record for that one little spot on our site. And of course, Rich Lamb and his staff reviewed all those documents. But just like kind of a bridge, we had our own inspectors take core and do those tests and keep track of that. So I think that's my answer for that one. And now it looks like we're over time. So I'll take more. I know, Rich, you're the expert, and we listened a lot to you, and you kind of were our knight in shining armor to go from the experimentation stage or feeling like when it's an experiment to the empowerment stage. So we do thank you for that.
Thank you.
Thanks so much, Adam, Kelly, Rich. And if we are going to share a last slide of all the presenters today, in case you would like to reach out, have further questions, their contact information is there. Definitely one giant round of applause for everyone today for sticking with us a little longer and bearing with us during some initial difficulties. And thank you to all of our presenters for being willing to connect across MnDOT to share your innovations, and encourage you to reach out with further questions. We have also an invitation from all of you to join our innovation community of practice. We will be having our first meeting in January of next year, and it's an opportunity to continue to connect, collaborate, and share and learn across the agency. If you are interested in joining us, we have a slide here with a QR code. You can also contact me or Taylor Schmall directly, and I will put our emails in the chat. So thanks again to everyone. Hope you learned as much as I did, and we look forward to seeing you at future Innovation Hour webinars. Have a great rest of your day. Thanks, everyone.